you might have seen this before as SOHCAHTOA, which stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And then this is in reference to a right triangle with a reference angle that we typically see as theta. Our H is our hypotenuse, the longest side across from the right angle. Adjacent is the side that isn't the hypotenuse touching the angle, and opposite is the side that doesn't touch my reference angle at all. So you've learned sine, cosine, and tangent. There are reciprocal trig functions, which are taking those three and then flipping them. They are cosecant, which is the opposite of sine, secant, which is the opposite of cosine, and cotangent, which is the opposite of tangent. So these are the 6 trig functions whenever it asks for 6 trig functions, the ones I've highlighted in pink. Then it wants me to recall the Pythagorean theorem is a squared plus b squared equals c squared, where c is always our hypotenuse, the longest side. So number 1 wants me to evaluate the 6 trigonometric functions of the angle theta. This angle right here is my theta. I don't know why that printed so lightly. I know this side and this side. I need to figure out this side. So I'm going to label A, B, and C. A and B don't matter so much as C. C is always the hypotenuse. So I'm going to plug into the formula I've highlighted in yellow. I'm going to have 5 squared plus 12 squared equals c squared. Five squared is 25. 12 squared is 144 equals c squared. $25 plus 144 is 169. Then I want to go ahead and take the square root of both sides. I can go to Desmos for this. I can type the letters SQRT, and it'll give me the square root, or if I click this keyboard, there's the square root option right here. Then I typed 169 to get 13. That was not the button I meant to press. So now I know my hypotenuse is 13. So then I want to find my trig functions. I have my sine of theta. Wait. Before I do this, I want to label my sides in relation to my angle. So my angle is right here. I have my hypotenuse. I have my adjacent, which is the side next to the angle. That isn't my hypotenuse. And then I have my opposite, the one that doesn't touch that angle mark I just drew. So now that I have this, I want to go ahead and plug in. Sine is opposite over hypotenuse. So my opposite is 12, my hypotenuse is 13. Then I have my cosine, which is adjacent over hypotenuse, which is 5 over 13. And my tangent is opposite over adjacent, so opposite, adjacent, 12 over 5. These ones should be kind of familiar because you should have done them back in geometry. Then I have my reciprocal functions. What reciprocal means is I take the fraction and flip it. So I have cosecant goes with sine. So I'm going to take the sine fraction and flip it. Then cosine matches up with secant, so I'm going to take that and flip it. And tangent matches up with cotangent, so I take that and flip the tangent fraction. Okay, so on this one, I want to start off by finding the length of my hypotenuse, so I'm going to label A, B, and C. I want to go ahead and plug back in. I'm going to have 7 squared plus 24 squared equals C squared. Seven squared is 49. 24 squared is 576. Then I add 49 and 576 to get 625. I take the square root of both sides, which gets me, 25. So now that I have all of my sides labeled, I can rewrite these in terms of adjacent, hypotenuse, and opposite. My angle that I care about is right here. So this is going to be my adjacent side. It's the side that's not the hypotenuse. This is my H for hypotenuse, and this is my O for opposite. Then I'm going to plug into my 6 trig functions. So I have sine of theta is opposite over hypotenuse. So 24 over 25. Then I have my cosine, which is adjacent over hypotenuse, which is 7 over 25. I have tangent, which is opposite over adjacent, so 24 over 7. Then I want to do my reciprocal functions. Cosecant goes with sine. So I flip the sign fraction. So now it's going to be 25 over 24. Then I want to flip cosine for secant. That's going to be 25 over 7. And I want to switch tangent for cotangent, which gives me 7 over 24. Moving on to the back. This one tells me in a right triangle that theta is an acute angle and gives me one of the trig values. Then it wants me to find the other 5 trig functions. So what I want to do for these ones is I want to start off by drawing a triangle. And I'm going to label my reference angle. Sine is normally opposite over hypotenuse. So on this triangle, my opposite is the up and down. My adjacent is the side to side, and my hypotenuse is the longest slanted side. Then I want to label the 4 and 7 for my opposite and hypotenuse. 4 was on top, so that's the opposite. 7 was on the bottom, so that's the hypotenuse. Then I want to use the Pythagorean theorem to find the missing side. I'm going to make this A, this B, and this one has to be C. So I'm going to plug in. I'm going to have A squared plus 4 squared equals 7 squared. A squared stays the same. 4 squared is 16. 7 squared is 49. Then I want to go ahead and subtract 16 from both sides. (49 minus 16 gives me 33. Then I want to take the square root of both sides, which gives me A on the left. On the right, I can't take the square root of 33 nicely, so this just stays the square root of 33. So I'm going to go label that back on my triangle. Now that I have that labeled, I can go find my other trig functions. So I need to find cosine, tangent, cosecant, secant, and cotangent. I forgot to say. So I'm going to find cosine first. That is adjacent over hypotenuse. That is square root of 33 over 7. Then I want to find tangent, which is opposite over adjacent. So 4 over square root of 33. When I have a radical on the bottom, I need to do something called rationalizing the denominator. This is getting the radical out of the bottom and making sure I have a whole number on the bottom. So to do that, I'm going to multiply the top and bottom by the square root of 33. So when I do that, on the top I'm going to get just 4 square root of 33, because I can't combine them because of the radicals. And on the bottom, when I multiply two of the same radical together, the radical just disappears, and it turns into a regular 33. Then I just need to find my reciprocal function. Cosecant flips the sine function, so it's going to be 7 over 4. Secant flips cosine, so it's going to be 7 over the square root of 33. Again, I don't want that radical on the bottom, so I'm going to multiply by the square root of 33 over the square root of 33. This will just give me 7 square root of 33 over 33. Then cotangent is going to flip the tangent, which would be square root of 33 over 4. Since my radical is on the top, this is fine.